Welcome to ITEDST, IS Data Structure. Introduction to Data Structure. Data structure can be defined as the group of data elements which provides an efficient way of storing and organizing data in the computer so that it can be used efficiently. Data structures are the main part of many computer science algorithms as they enable the programmers to handle the data in an efficient way. It plays a vital role in enhancing the performance of a software or a program, as the main function of the software is to store and retrieve the user's data as fast as possible. Data. Data can be defined as an elementary value or the collection of values. For example, a student's name and its ID are the data about the student. Group items. Data items which have subordinate data items are called group item. For example, name of a student can have first name and the last name. Computer data is information processed or stored by a computer. This information may be in the form of text documents, images, audio clips, software programs, or other types of data. Computer data may be processed by the computer's CPU and is stored in files and folders on the computer's hard disk. At its most rudimentary level, computer data is a bunch of ones and zeros known as binary data. Because all data is in binary format, it can be created, processed, saved, and stored digitally. This allows data to be transferred from one computer to another using a network connection or various media devices. It also does not deteriorate over time or lose quality after being used multiple times. Group items refer to data items that can be divided into sub-items, which is called group items. For example, the name of a person is a group item because it can be divided into 3 sub-items like first name, middle initial, and last name. Other examples are address, date, qualification, and salary. Record. Record can be defined as the collection of various data items. For example, if we talk about the student entity, then its name, address, course, and marks can be grouped together to form the record of the student. A record is a data structure that groups together related items of data. These are slightly more complex than arrays, as you can store more than one type of data together. For example, with a game, it could be useful to set up a data structure which collects a player's login and their score in one structure. File. A file is a collection of various records of one type of entity. For example, if there are 60 employees in the class, then there will be 20 records in the related file where each record contains the data about each employee. A file is a collection of data stored in one unit. It is identified by a file name. It can be a document, picture, audio or video stream, data library, application, or other collection of data. Attribute and entity. An entity represents the class of a certain objects. It contains various attributes. Each attribute represents the particular property of that entity. Field. Field is a single elementary unit of information representing the attribute of an entity. In computing, an attribute is a specification that defines a property of an object, element, or file. It may also refer to or set the specific value for a given instance of such. For clarity, attributes should more correctly be considered metadata. An attribute is frequently and generally a property of a property. An entity is any singular, unidentifiable, and separate object. It refers to individuals, organizations, systems, bits of data, or even distinct system components that are considered significant in and of themselves. The basic difference between entity and attribute is that an entity is a distinguishable real-world object that exists, whereas attribute describes the elementary features of an entity. Processor speed. To handle very large amount of data, high-speed processing is required. But as the data is growing day by day to the billions of files per entity, processor may fail to deal with that much amount of data. In computer language, there are what are known as cycles. Cycles are groupings of information. A cycle is completed when all of the instructions in the group have been processed. Processor speed is the number of cycles per second at which the central processing unit of a computer operates and is able to process information. Processor speed is measured in megahertz and is essential to the ability to run applications. Faster processor speeds are desirable. Data search. Consider an inventory size of 106 items in a store. If our application needs to search for a particular item, it needs to traverse 106 items every time, results in slowing down the search process. Searching in data structure refers to the process of finding location of an element in a list. This is one of the important parts of many data structures algorithms, as one operation can be performed on an element if and only if we find it. Various algorithms have been defined to find whether an element is present in the collection of items or not. This algorithm can be executed on both internal as well as external data structures. The efficiency of searching an element increases the efficiency of any algorithm. Multiple requests. If thousands of users are searching the data simultaneously on a web server, then there are chances that a very large server can fail during that process. In order to solve the above problems, data structures are used. If a server uses a number of sub-processes in order to serve multiple requests by allocating each socket to one sub-process, then it is known as a multi-threaded server. This is how the server handles multiple connections at a time. Data is organized to form a data structure in such a way that all items are not required to be searched, and required data can be searched instantly. Efficiency. Efficiency of a program depends upon the choice of data structures. For example, suppose we have some data and we need to perform the search for a particular record. In that case, if we organize our data in an array, we will have to search sequentially element by element. Efficiency signifies a peak level of performance that uses the least amount of inputs to achieve the highest amount of output. Efficiency requires reducing the number of unnecessary resources used to produce a given output, including personal time and energy. It is a measurable concept that can be determined using the ratio of useful output to total input. It minimizes the waste of resources such as physical materials, energy, and time while accomplishing the desired output. Hence, using array may not be very efficient here. There are better data structures which can make the search process efficient, like ordered array, binary search tree, or hash tables. Reusability. Data structures are reusable. That is, once we have implemented a particular data structure, we can use it at any other place. Implementation of data structures can be compiled into libraries which can be used by different clients. The capability of using all or the greater part of the same programming code or system design in another application. Very few information systems are designed and written entirely from scratch. Existing procedures are widely used, although often with a lot of modification, and applications are built upon frameworks from the software companies and routines that programmers have written in the past. Abstraction. Data structure is specified by the ADT, which provides a level of abstraction. The client program uses the data structure through interface only, without getting into the implementation details. Abstraction in its main sense is a conceptual process where general rules and concepts are derived from the usage and classification of specific examples. Its main goal is to handle complexity by hiding unnecessary details from the user. That enables the user to implement more complex logic on top of the provided abstraction without understanding or even thinking about all the hidden complexity. So these are our data structure classification. So data structure is divided into two parts. We have the primitive and non-primitive data structure. And part of it is the linear and the non-linear, which is again composed of static and dynamic for linear and tree and graph for non-linear. While in the static, we have the array, and in dynamic, we have the linked list, the stack, and the queue. Linear data structures. A data structure is called linear if all of its elements are arranged in the linear order. In linear data structures, the elements are stored in a non-hierarchical way where each element has the successors and predecessors, except the first and last element. A linear data structure is a structure which the elements are stored sequentially, and the elements are connected to the previous and the next element. As the elements are stored sequentially, so they can be traversed or accessed in a single run. The implementation of linear data structure is easier as the elements are sequentially organized in memory. The data elements in an array are traversed one after another and can access only one element at a time. The types of linear data structures are array, queue, stack, and linked list. Arrays. An array is a collection of similar type of data items, and each data item is called an element of the array. The data type of the element may be any valid data, like a character, an integer, a float, or even a double. An array is consists of data elements of a same data type. For example, if we want to store the roll numbers of 10 students, so instead of creating 10 integer type variables, we will create an array having size 10. Therefore, we can say that an array saves a lot of memory and reduces the length of the code. The array can be one-dimensional, two-dimensional, or even multi-dimensional. The elements of array share the same variable name, but each one carries a different index number known as the subscript. In this example, we are using a one-dimensional array that can handle 5 data entry. Linked list. Linked list is a linear data structure which is used to maintain a list in the memory. It can be seen as the collection of nodes stored at non-contiguous memory locations. It is a collection of nodes that are made up of two parts, that is the data element and reference to the next node in the sequence. So in this example, each node of the list contains a pointer to its adjacent node. A stack is a linear list in which insertion and deletions are allowed only at one end, called top. A stack is an abstract data type that can be implemented in most programming languages. It is linear data structure that uses the LIFO, or the last in first out rule, in which the data added last will be removed first. The addition of data element in a stack is known as a push operation, and the deletion of data element from the list is known as pop operation. It is named as stack because it behaves like a real-world stack. For example, piles of plates or deck of cards. When the object is added to a stack, it is placed on the top of all previously entered items. When an item is removed, it can either be removed from the top or it could also be removed from the bottom of the stack. Queue. Queue is a linear list in which elements can be inserted only at one end, called rear, and deleted only at the other end, called front. It is an abstract data structure similar to stack. It is a data structure that uses the FIFO rule, or the first in first out rule. In this rule, the element which is added first will be removed first. There are two terms used in the queue, front end and rear. The insertion operation performed at the back end is known as add enqueue, and the deletion operation performed at the front end is known as dequeue. Queue is open at both ends, therefore it follows the first in first out methodology for storing the data items. A queue is a list of jobs that are awaiting to be processed. When a job is sent to a queue, it is simply added to the list of jobs. Computer programs often work with queues as a way to order tasks. For example, when the CPU finishes one computation, it will process the next one in the queue. Non-linear data structures. These data structures does not form a sequence. That is, each item or element is connected with two or more other items in a non-linear arrangement. The data elements are not arranged in sequential structure. A non-linear structure is also another type of data structure in which the data elements are not arranged in a contiguous manner. As the arrangement is non-sequential, so the data elements cannot be traversed or accessed in a single run. In the case of linear data structure, element is connected to two elements, previous and the next element. Whereas in the nonlinear data structure, an element can be connected to more than two elements. Trees. Trees are multi-level data structures with a hierarchical relationship among its elements known as nodes. The bottommost nodes is the hierarchy, which is called leaf, while the topmost node is called the root node. Each node contains pointers to point adjacent nodes. It is a nonlinear data structure that consists of various linked nodes. It has a hierarchical tree structure that forms a parent-child relationship. Tree data structure is based on the parent-child relationship among the nodes. each node in the tree can have more than one children except the leaf nodes, whereas each node can have at most one parent except the root node. Types of nonlinear data structures. So we have graphs. Graphs can be defined as the pictorial representation of the set of elements, which is represented by vertices, which is also connected by the links known as edges. A graph is different from tree in the sense that a graph can have cycle while the tree cannot have the one. A graph is a nonlinear data structure that has a finite number of vertices and edges. And these edges are used to connect the vertices. The vertices are used to store the data elements, while the edges represents the relationship between the vertices. A graph is used in various real-world problems like telephone networks, circuit networks, social networks like LinkedIn, Facebook. In the case of Facebook, a single user can be considered as a node, and the connection of a user with others is known as edges. Traversing. Every data structure contains the set of data elements. Traversing the data structure means visiting each element of the data structure in order to perform some specific operation like searching or sorting. For example, if we need to calculate the average of the marks obtained by a student in 6 different subjects, we need to traverse the complete array of marks and calculate the total sum. Then we will divide that sum by the number of subjects, that is 6, in order to find the average. Insertion. Insertion can be defined as the process of adding the elements to the data structure at any location. If the size of data structure is n, then we can only insert n-1 data elements into it. Insert operation is to insert one or more data elements into an array. Based on the requirement, new element can be added at the beginning, end, or any given index of array. Here, we see a practical implementation of insertion operation where we add data at the end of the array. Deletion. Deletion refers to removing an existing element from the array and reorganizing all elements of an array. The process of removing an element from the data structure is called deletion. We can delete an element from the data structure at any random location. If we try to delete an element from an empty data structure, then underflow occurs. Underflow is a condition which occurs in a computer or similar device when a mathematical operation results in a number which is smaller than what the device is capable of storing. Similar to overflow, underflow can cause significant errors. Searching. The process of finding the location of an element within the data structure is called searching. There are two algorithms to perform searching: linear search and binary search. Searching is the process of finding a given value positioned in a list of values. It decides whether a search key is present in the data or not. It is the algorithmic process of finding a particular item in a collection of items. Searching algorithms are designed to check for an element or retrieve an element from any data structure where it is stored. Sorting. It is the process of arranging the data structure in a specific order, which is known as sorting. Sorting is the process of arranging data into meaningful order so that you can analyze it more effectively. There are many algorithms that can be used to perform sorting. For example, we have insertion sort, selection sort, and bubble sort. Merging. When two lists A and list B of size M and N respectively of similar type of elements clubbed or joined to produce the third list, list C of size m plus n, then this process is called merging. Merging two arrays is similar to concatenate or combine two arrays in a single array object. We have to merge two arrays such that the array elements maintain their original order in the newly merged array.